Hello viewers and students, this is Turning Point Tutorials. We are here again today to look at another round of lectures, and today we are discussing a topic in mathematics, and that's mensuration. This topic will help those students who just enter the senior secondary level, that's SS1 students, and this topic is very broad. We are looking at mensuration. Mensuration. When we talk about mensuration, as I said, it's a very broad topic. We are going to break it down into two broad aspects. That is plane mensuration and solid mensuration. Plane mensuration and solid mensuration. So, number one, we're looking at plane mensuration. Number two, we'll be looking at solid mensuration. So we'll look into plane mensuration as the first aspect. Before we go into plane mensuration, when I say plane mensuration, we're looking at two-dimensional shapes. Okay, so let's talk about the first one, plane mensuration. And under this, we'll be looking at types of plane shapes. Types of plane shapes. Types of plane shapes. So I am not here to go into calculation. I'm here to give you introduction and show you some of the formulas, possibly how we derive those formulas, and then you are enjoying to look at those formulas and put them in your memory, because in this topic, mensuration, the formula is key to solving any question. Even if you know the procedures, you know the tactics to get the answer right, but you don't have the formula with you, you'll be stranded. So I will present to you the formulas you need to tackle any of this topic under this plane mensuration. So let's go back to look at types of plane shapes. Number one, we'll be looking at circle as one of the plane shapes, and two, we'll look at square. Three, we'll look at rectangle. Four, we'll consider parallelogram. Five, we'll look at triangle. 6, we'll consider trapezium. 7, we'll look at rhombus. And 8, look at kites. So, viewers, these are the types of plane shape we want to consider, and the formulas that are necessary to calculate anything concerning these plane shapes. So I will begin with the circle. Let's look at circle. Number one, look at circle. Now, as simple as this shape, there are a lot of formulas we can derive from it. But before I go on, I would like to talk about some properties that you will need, not only for this topic, we also need them in topics like psychogeometry. Let's look at this. This is a circle. Alright. I will assume the center, that's the center of the circle, and from there we can look at other properties. Now, on this circle, in your primary school days, you were taught the area of the circle. So I'm taking the first formula, the area of a circle, and you also taught the perimeter, which you can also call the circumference of a circle. The perimeter, or in brackets call it circumference. Permit me to use abbreviation OCE of a circle. your first formula, pi r squared. Second formula, 2 pi r. This is the basic formula you can find in circle. Now there are other formulas you can derive from this same circle. Alright? Now, then we look at circumference. When we say circumference, we're talking about the distance around a particular point. This is a point here. So if I go round, that's the circumference of the circle. Okay? Then we have a point here. I create a point here. Okay? At this point, I call it A. Create another point here and call it B. Now, from this diagram, I discover that I have divided the circle into two arcs. So that leads me to the second formula, the third formula, which is your length of arc. Length of arc. Now, from what you see here, you see that the two arcs, they are not the same length. Of course, beginning from this side down, following side down to this side, if you compare it to the other side, there's a big difference. If you go like this, turn around, back to this side, there's a big difference. So this is, from this side to this side, is the minor arc, or a small arc. Then this side, from here to this other side, is the major arc. So what is the length of arc formula? The length of arc formula is theta over 360 degrees times 2 pi r. This is the length of arc formula. So anytime you want to calculate length of arc, this formula you're going to apply. Mind you, I told you that we're not going to calculations today. Let's just see if we can get formulas down. In next class, we're going to dig deep into this and see how to apply these formulas. So that's length of arc. Then there is what we call a radius. From there, I will look at other issues. From here, if I draw a line from the center to touch any parts in the circumference, that's called a radius. Radius to any direction in the circle is the same. If you draw it from this side to this side, radius is radius. This is radius, this is also radius. Okay, so if I take another radius to this direction, that will produce two different areas. There's area here, there's another area here. So this area is called the sector, or we'll call it the minor sector. And this other area, okay, let me try if I can shade it. This area now is what we call the major sector. The major sector. Okay, so that leads me to another formula. What is the area of sector? Area of sector is theta over 360 degrees multiplied by pi r squared. So this formula is necessary to calculate area of a sector. Now, with this, we want to graduate. There's what we call chord. What is a chord? A chord is a line that divides a circle into two unequal parts. Take note. A line a chord is a line that divides a circle into two unequal parts. Mean that a line is different from a diameter. Then what is a diameter? A diameter is a line that passes through this center of a circle, dividing the circle into two equal semicircles. So if I draw a circle, and this is the center of the circle, and I pass through the center, this is a diameter. But if I go like this, this becomes a chord. So this is a chord, this is a diameter. So it's a diameter because it's passing through the center. It is a chord because it's not passing through the center. That is one good point you should take note. And mind you, the direction with which you draw the chord is immaterial. So if I draw a circle like this, and I put the line across, this is a chord, this is the center of the circle, this is a line, this is a chord. Whether I draw this direction or this direction, a chord remains a chord. So what is the length of chord? Create another formula now. Length of chord. Length of chord. I need to put it down here. Length of chord. That's so radius sine theta over 2. This formula will help you when you're calculating length of chord. Then we can graduate into another property in a circle called segments. Segment. A segment is another area in the circle that is quite different from a sector. How do you form a segment? A segment is formed from the creation of a chord. So when you draw a chord across a circle, it will create two unequal segments, the major and the minor. Let me use a smaller circle to demonstrate that. So if we have a circle here, this is the center of the circle, and I pass through. So what I've done here, this line is called a chord, creating two unequal segments. So if I shade down this way, this is a minor segment, and this side is the major segment. So get that clear. So you'll be asked two things in the segment. You'll be asked to calculate the area of the segment and also the perimeter of the segment. And you need the formula so you don't mix them up. Okay? Now, what is area of segment? Take on that formula now. Area of segment. Area of segment. You must understand something. To get area of segment, you must get a property here. So I'll assume the center of the circle, I'll draw a radius, I'll draw another radius. This is a radius, a radius. And from what you see, remember that radius is radius. So if this side is a radius, this side is a radius, that means this line and this line, they are equal. Meaning that this triangle that is not shaded is an isosceles triangle. Isosceles triangle has two sides equal. So now, from this whole diagram here, you see that there's a sector here. It's a sector here. Okay? So if you cut out this triangle, this isosceles triangle, if you cut it out, discover that what we left behind is just this shaded part, which is the area of segment. So if you cut this thing out, let me bring it out so you see very clearly. So this is now the area, this is segment now. So if you cut this thing out, what will be left is the area of the segment. So what is area of segment? Now, area of segment is the area of the whole sector, because this is now a sector. The area of the whole sector minus the area of the isosceles triangle. So that's the area of sector minus area, or let me write it where it's minus area of isosceles triangle. Let me have it. So what's the formula? Area of sector is theta over 360 times pi radius squared minus area of isosceles triangle, that's 1 over 2 r squared sine theta. This is the area or formula to calculate area of segments. Alright, we'll graduate from there. We'll now look at the last thing, which is now the perimeter of segments. What's perimeter? Perimeter is a distance around a shape. So if I cut this out, this is what I'm going to get. This is now the sector. Sorry, yes, the segment rather. This is now the segment. So see that segment comprise length of chord plus length of arc. So from here to this side is length of chord, while from this side to this side is length of arc. So let's go. Now, next thing now is perimeter of segment. Perimeter of segments. Okay, so that's length of chord. Sorry, length of chord plus length of arc. What length of chord? Can go back. This length of chord 2 radius sine theta over 2. Length of arc theta over 360 multiplied by times 2 pi r. So these are the formulas you need in a circle. So with these formulas, you can calculate anything you want to calculate in a circle. So we'll move on to the next shape. Next shape before us is a square. So from what you are seeing, I see that in a day we cannot exhaust this in calculation. So let's go to the next shape. That's a square. Let me just remind you, this is the shape of a square. Don't forget that all sides are equal. Don't forget that all angles are equal, 90 degrees. Okay? So now what formulas you need? Simple formulas like this. Look at the area of a square. Let's say area of a square is, since all sides are equal, this side is equal to this side. So it's two-dimensional. So length times length will give you L squared. So if you find one side, multiply it by 2, you get the area. Then we'll look at perimeter. Since all sides are equal, length, 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 because perimeter distance around a shape, you add up all the sides, you get perimeter of the square. So L, length plus length, you get 4L as the perimeter of a square. So with that, I'll move on to looking at the next shape, which is a rectangle. Rectangle. In this rectangle, of course, you'll be asked to find area, which you already know. You have a sort of knowledge, length and breadth. Then 2, you look at the perimeter, which is 2, open bracket, length plus breadth. Then you can take other aspects in a rectangle. Don't forget that the other question will ask you. Okay? You have rectangle. Don't forget the diagonal. You can be asked to find the diagonal. Okay? Where you apply Pythagoras rule, the diagonal. Okay, they don't give you the breadth, they remove the breadth, and then they give you the diagonal. Let's say 5, and then they give you the length, let's say 3. You can use Pythagoras rule to get the other side, which is breadth. So now go to, let's take rectangle. Let's take triangle. Triangle. Now, triangle is another aspect of the plane. It's another plane shape that we need to consider. Now, this shape is very special because we have different forms of it. We have basically 4 types of a triangle. We have the right angle triangle. We have the scalene triangle. For scalene triangle, you know that no side is equal. Okay. Then we look at the isosceles triangle, which has 2 sides equal, and then the base angles also equal. They also have an equilateral triangle that has all sides equal and all angles equal, which is 60 degrees. Then we look at this, basically this formula to solve equation triangle. What's the area of triangle now? Area of triangle, look at half multiplied by the base times the height, that's half BH. Then 2, we consider another formula. Let me just call this one area 1. The formula calculates area of triangle, area 1. Then look at area 2. Area 2. You can also calculate area of triangle using what we call the Hero's formula. The Hero's formula. Okay? Which is the Hero's formula, which is the square root. The square root of S into brackets x minus a, open x minus b, open x minus c. Okay, now where your a, b, and c are the 3 sides, of the triangle, and then your S is the average. Okay, is the average a plus b plus c divided by 2. That's the average. So now from what we have, you see that we can use this formula to calculate triangle, having like this is Hero's formula. Mind you, you can check your see Hero's formula. Then let me just add one more, which is area theory. You can also solve triangle using this formula. Half AB sine theta. Okay, where 2 sides is given to you and 1 angle. So you can use this formula to solve. So because of time, we are going very fast. So we'll come back in the next class and we'll consider all the formulas you can find in this plane mensuration. Thank you very much for viewing.